show that MR is equal to 1/3 all of U plus 2V. What we have here is another take on the previous audiovisual in which we were required to show that MR is that expression. We also promised that if we took another route, that the expression will still be the same. And that is what we are setting out to show in this particular audiovisual. Now, PQRS is a parallelogram, and because it is a parallelogram, we know that opposite sides will represent the same vector. Therefore, the vector that is here that we are not showing, maybe because it is not going to be relevant to the solution of this problem, is equal to the vector here. The vector here is also equal to the vector which is here. And that one is relevant, therefore we are demonstrating that in great detail. MR is what we are about to express in the required form. We are now going from M to Q and then from Q to R. And we see that this entire line segment is divided into 1/3 and 2/3. We also know that the vector that goes from Q to S is V minus U. In this direction, it is V minus U. Notice that when we are going from M to Q, we are going in the opposite direction. QS is V minus U. If we are going from M to Q, we are going in the opposite direction, and we are going 1/3 of that journey. Therefore, the vector that goes from M to Q is 1/3 of this entire vector. But because we are going in the opposite direction, we accompany that by a negative sign. And that is true universally for vectors, that if we are going in the opposite direction to a particular vector, then that motion is negative of the vector. And we are going in the opposite direction to QS. And we are going 1/3 of the journey. So negative 1/3 of QS, which is negative 1/3 of V minus U. The other one is straightforward. We are going in the same direction of V plus V. We will now expand the brackets, but we cannot do so without considering the manipulation of directed numbers. Negative times positive will give negative. We therefore have a negative 1/3 V. Negative times negative is positive. We therefore have positive 1/3 U. And we will also make an adjustment with V in such a way that all of the terms will have a denominator of 3. We will achieve that by multiplying V by 3/3, meaning that we are multiplying both numerator and denominator by 3. Of course, we can easily see that this will cancel with this, and the value is the same as what we had before. But we are writing it in a form in such a way that it is easily combined with what we have right there. And we will see that negative 1/3 V plus 3/3 V will give us 2/3 v. And of course 1/3 u will return just as it is. So 1/3 of u returns just as it is, and we have negative 1/3 v plus 3/3 v is equal to 2/3 of v. Or we may look at it the other way around. 3/3 v minus 1/3 v is equal to 2/3 of v. We will take out a common factor of 1/3. If we take that out, we will have 1/3 u plus 2v, which is what we have right there. No doubt about it. Or we may place the expression over a common denominator of 3. Take the expression, express that over 3, all over 3, because the common denominator is 3 already. So there's no groping to find a common denominator. And after doing that, we may place 1/3 at the front and u plus 2v in brackets. And that will be the same as the expression that we have right there, which is the required form of the vector mr. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.